we've taken a look at some of the secondary effects that can kind of influence how we do our designs, I want to come back to the characteristics of the major climate zones. And so we're going to take a much better look here at how each one of these climates really differs from one another, with the temperate, the tropical, and the dry land climate zones. So when we look at the temperate zone, we remember that this is the cold, cool, warm, kind of Mediterranean-ish kind of climates. And in these climates, when we look at the soil, so when we're looking at what's happening at ground level, and we're looking at the actual biomass that's in the soil, so the biomass just being the phytomass plus the zoomass, these soils typically tend to be very, very deep and very fertile soils that we have in the temperate climate. And 60% of our life, of this biomass, so this animal life and plant life, is above the ground, and 40% of it is below the ground. So in this climate, there is a dormant period in the winter, and we tend to grow all of our food in the summertime. And when we look at the animals in this type of a system, they all tend to live in the larger quantity of the animals tend to live and sleep and hibernate and die in the ground. There's lots and lots of earthworms and soil life and burrowing animals and things like that. There are a lot of herbs in this kind of climate. So herbaceous species just being kind of non-woody stems of plants. We have lots of deciduous leaves in this climate. So a lot of the plants will lose their leaves in the winter and regrow new ones each year. And the soil that we have in this type of a climate, because it's so rich and deep and fertile, we can till it or plow it or mulch it. We can move it around. We can work it. It's really, really quite workable soil for the most part. So as far as a worldwide perspective goes, this is the easiest climate to live in and to be sustainable in. And it's also the easiest one to grow things in, because the light is very gentle in this climate, and the daylight is extraordinarily long in the growing season. And you also get a fresh start every spring. So the winter in this particular climate acts like a sterilizing event, where it's going to take out a lot of seeds and a lot of weeds and a lot of things for you, and then you get to start fresh every year, which is the point that I get to every year where I get really excited. Is sometimes in fall, if I haven't had enough time to work out in my yard or out on my farm at all, I really look forward to winter to come along and wipe everything out so I can start fresh the next year. And when we look at the weeds in this particular climate, the weeds in a temperate climate tend to be herbs. So herbs, again, in this case, meaning kind of non-woody stemmed plants. And so all of the surplus organic matter in this climate is herbal in nature. It's non-woody stems. It's just very lush greenery that tends to be our surplus organic matter. If we try to break down trees in this climate, like in a hugelkultur bed, for example, the winter will help break that stuff down the most. and we can use that to help prepare the soil the following year. But for the most part, we want to be using plants as mulch because they might break down within that same growing season. And so this brings us to the tropics. And the tropics are going to vary in the sense that with their soil is much, much different than it is in the temperate climates because it's very shallow and there really isn't much of it. When you think about topsoil or actual, soil that's good to grow in, there's very, very little of it. So there's a tiny bit of rich soil at the surface, and then it goes down into subsoil, which can be very easily eroded over time. So some of the facts of the tropics. So basically in this case here, like you have a tiny little bit of actual decent soil on the top, but most of it is all subsoil. And so in the tropics, you tend to get most of your rain in the winter and most of your sun is in the summertime. And 90% of the life, so with a temperate climate we had 60 and 40, and with the tropics we end up with 90% of our life lives above the soil and only 10% of it lives in the soil. Because the system is so moist and hot and everything, it has a tendency to be a very, very quick cycling system. There is a very small time when it will slow down, when the decomposition will slow down, and that's typically during the dry period. And when you get within the tropics, as you're coming from the subtropics to down to where the equator is, right at the equator, you actually get a situation where everything lives above the ground. You really don't have anything that's living in the ground. So the animals in these climates, they don't burrow. They're not burrowing types of animals. They live in the trees. They die in the trees. They sleep in the trees. And there's very few earthworms because they would drown in the ground. The rains are just too heavy in this climate. There's a lot of woody growth, and there's very fast decomposition of things. It's very easy to erode this soil. There's very heavy rains, and it can really wear you out if you don't get it right because it moves so quickly. And there's never really been a successful, sustainable, large-scale agriculture in the tropics. So although we're trying to industrialize some of these crops in later years, the way that they're being grown isn't in a sustainable fashion. And so any of the large agricultural commercial type products that are coming out of the tropics are quite destructive in nature. So if we look at even just the difference between the temperate climate and the tropics, we don't want to move very many things from our design aspects of our temperate climate into the tropics. It's just not going to work. So having said that though, in the tropics the regrowth is absolutely rampant, and so it will recover very quickly if you do the wrong thing. It goes out of production quite quickly as well, but it will stack carbon very fast. So the response of most individuals currently is to usually burn the extra vegetation in a tropical climate, and they burn during the dry period and plant just before the wet season. And that way you can continue to exhaust the soils over and over and over again. It's not a really good system. So when you force large animals onto systems in the tropics, you end up with a pasture that needs to get burnt every year because it gets so tall that you actually wouldn't be able to find your cows. Like a lot of times the pasture could be 2 to 3 meters high in just a very, very short period of time. And it's all fiber, but none of the goodness that the cows actually need. So you need a lot of high shade in the tropics, and you want to look at how much aquaculture can you get into a system, how many wet mulch pit type systems can you put in. And the tropics is full of a lot of wonderful trees, but they're not very resistant to soil problems because there's so little soil for them to live in. So most of the treed systems in the subtropics are actually rooting in and based into the subsoil, not the soil itself. And if you travel to tropical places and you see a bunch of that really, really red soil, that's actually the subsoil. Their actual topsoil, like the actual good growing soil, will be a dark brown. You just don't see very much of it at all. And when we look at the weeds in a tropical system, instead of being herbaceous plants, they are actually usually more like woody bushes. There's very little just herbaceous growth for the most part. And so these woody bushes are your surplus organic material. And so when we're decomposing wood in a tropical system, we're actually decomposing it at the surface, not underground like we would in the temperate climate. And if you try to use herbs as organic matter here, so as mulch or anything like that, you'll just get worn out because the decomposition happens so quickly that you won't be able to keep up with it. And so the mulches in these kinds of areas are like large banana leaves and sticks and entire trees that are laying down, and that's like really, really rough mulch in the tropics so that it doesn't break down quite so quickly. And then when we move into the dry lands, people don't really think of it this way, but the dry lands actually have quite good soils. There's a reasonable depth to the soil, and again, like the temperate climate, in this case, actually most of the animals live and die and sleep underground because they have to get out of the shade. So they would live in caves or they would live in burrows to get out of the blinding sun. So in a dry land system, the main issue that you face is the fact that it's deficient in water. You can grow things very, very easily in the dry lands. All you have to do is just toss water on it. But how we get that water is not easy whatsoever. So everything that you try and do when you're doing a design in dry land is to try and gain more water on your land. So in the dry lands, there's actually a lot of high quality residual nutrient. It just doesn't decompose because there isn't enough water. So you'll have mulching potential there, but it won't break down because everything's too dry. There's very, very long cycles as a result. Things are not going to cycle through really quickly. And unless you extend the water and you are able to gain more water on that property, you're not going to get very much of a result whatsoever. But because everything is so concentrated there, the food grown in dry lands is very often the quality of the food in the dry lands is some of the highest that you'll experience anywhere. And we really need to look at good positions for our design in order to actually be sustainable in the dry lands. So for example, you need to increase shade. You cannot survive if there isn't shade in the drylands. Animals live in the shade, they die in the shade, they sleep in the shade, which is why there's so many that burrow underground and live in caves. A lot of the animals will hunt at night. They'll move a lot into night activity in the drylands. So we can increase and extend some of our water by creating more shade and increasing the amount of shade that we have. We really need to cool the temperature somehow as well. And in order to do that, we may need to go down to the ground ourselves. And when we go down into the ground itself is cool as well, which will help us out. The system is very time dependent. You have to be able to do things at the right time in order to do this correctly. So it's the easiest system to damage and to keep damaging. It's very easily shattered and destroyed. And it sits there ready to recover, but it won't do it on its own. And you can recover it quite quickly when our participation is there, but on its own, it will take forever to really kind of recover on its own. So if you choose the right positions and you have the right design, though, it does produce quite well. The nutrients are there and the potential is there. And again, like the easiest way to get production in these drylands is to just dump water on it, and then you'll be able to grow anything you want. But the way that we're adding water can very often have its own problems as well. So there's so much evaporation that takes place in these drylands that we have to be very careful, because if we do the wrong thing with water, and it all evaporates, then the residual salt that was in that water is left behind when the evaporation happens. And we just end up with a salination of soils, which is very, very difficult to remedy. So we could use some of the water that's just under the surface if we're doing the right thing, because obviously it can be depleted very, very quickly. If we tend to use any sort of water that's flowing over the landscape, it's already been partially evaporated by the time it usually gets to us, and it tends to be saltier for that exact fact. And if you throw the water onto the landscape, no matter where the source is, without shading, the water is going to evaporate and cause saltier soil still. So at this point, if you really, really, really salinate the soil, it could take up to 1,000 years for the landscape to heal on its own. So we can speed that up, but sometimes it's not an economic thing to do either. So here, when we look at the types of plants that occur in the drylands, we have a mixture of herbs and trees. So the herbs usually will show up right after the rain, because there's probably only 1 or 2 instances a year where it's going to actually rain. The trees can be very, very hardy. They're quite specific trees. You don't get a lot of diversity in different kinds of trees, but they're extremely well suited to this kind of an environment. And we're trying to get some sort of decomposition out of these events of having these plants come up if we possibly can, because the soil is like a mouth that you're trying to feed with a lot of these plants. And if we get the soil right, it's going to have a lot of fungi in it. And the fungi is like the teeth that can break down all the woody parts for us as well. Which brings us to how to mulch all of these areas. And it doesn't matter whether you're in the temperate, the tropical, or the dryland type climate, you typically want to cut down your main mulch at the end of the dry season. So in the temperate climate, that means at the end of summer, you want to cut down all of your mulch so it can break down over the winter time. And that makes your garden all ready for the spring. In the tropics, at the end of a really dry winter period and at the start of the summer rains, that's when you want to cut down the mulch. But that's not what people do. They usually cut it at the start of the dry season and then they burn it. And so all of that mulch potential is gone. So if we teach them to mulch it instead, then when they cut at the start of the dry season, then there isn't, when they're currently cutting at the start of the dry season, what's happening is there isn't as much shade and things just fry. So if you cut at the end of the dry season, which should be the pattern for all three of these systems, then that material, especially in the tropics, will get broken down and pounded into more soil. And by the time it's the dry period again, most of that shade and foliage will have regrown to produce more shade when it gets really hot out again. And in the desert, when we look back at the timing factor of everything, because it rains so infrequently, you have to work extremely hard when it is raining. So it's actually quite easy to make the desert green. You just chuck a lot of water on it. But how can you keep it green? And can you have a sustainable water supply? So it's our job to get the water into the soil and out of the sun by creating a lot of shade. So in the desert, you very often want to catch 20 times the amount of water that you actually need to farm. So for example, you want to catch 20 acres worth of water to farm 1 acre of land. That's the good positioning aspect of it. So we can't populate the whole desert. Otherwise, we're not going to have enough water to be able to keep everything green. That being said, though, like some of the healthiest population is actually in the desert drylands because the nutrient density of this food is so much higher and the quality of the forage is quite high as well. And if you look at the greening in the desert examples in Jordan, Jeff Lawton videos, I'm sure you can find them on YouTube. He goes into a lot of detail as to how he did green the desert, and it's very impressive. It takes a lot of really smart design, but it definitely can be done.